Hi everyone. I'm going to talk about serverless, serverless and Docker. So who am I? Why am I here? I work for Docker, which is the container thing. But I'm not going to talk entirely about Docker. And in fact, a lot of this talk isn't to do with Docker at all. It's kind of to do with a lot of context about this sort of thing. So to start with, I'm going to sort of wave my hands and philosophize a bit about this sort of thing. And then in case you're really confused or fallen asleep, I will then actually show something real that you can do. And then I'm going to wave my hands and philosophize a little bit more. So let's start with what is serverless. And everyone's talking about this right now. But what is actually serverless? I'm guessing most people are familiar with this. Is just out of interest, is anyone here does not know what serverless is? Cool, to everyone. That shows what a pervasive thing it is. And the idea is that you write your application as a series of functions, which are triggered based on various things. So the popular one right now is the one that popularized it is Amazon Lambda. And the idea with Amazon Lambda is that you upload your function to Amazon, and then you can trigger that function, that piece of code, based on a bunch of things that happen on Amazon. So if you upload a file to S3, you can, for example, resize an image that gets uploaded to S3 automatically. And you don't have to worry about deploying servers, and you don't have to worry about scaling this thing. It just sort of runs in the cloud. And there's this kind of ridiculous notion, as with a lot of new technology at the moment, that serverless is going to kill containerization. And obviously it's ridiculous. Technically it doesn't make any sense because you still, need to run this code inside something. And an ideal thing for that is containers. And, serverless is not killing containers in the same way that, serverless is still servers. And I'm not sort of annoyed by this notion as someone coming from the container world. It's just kind of boring. It's kind of, there's so much more to all of this stuff than Amazon Lambda. And it's part of a sort of big shift in how we're sort of writing applications. And both serverless and containerization are tools in our toolkit for building these sorts of applications. So to help us understand how these things fit together and how serverless and containers can work together, I think it would be helpful to explain a bit of context here. And in context, I mean, let's go back in time. So back in time when computers were enormous things and they filled complete rooms and they were very, partly expensive, but also very long-lived and hard to change. Over time, we got smaller computers. And in the server world, at least, we had lots and lots and lots of smaller commodity hardware. They still filled rooms, but they were, smaller commodity machines. But even these things were a bit too sort of large and hard to manage, so we created virtual servers. So we could slice up these computers. But these virtual servers were still slow enough that you had to realize they existed. They still took a minute to boot up and a minute to shut down again. So we still sort of, unless you were Google or Netflix or something like that, we still generally managed them as if they were normal computers. But then we got some really, really small VMs. You all know what this is. This is containers. And something sort of weird happened with containers where they were so fast and efficient, you may as well wrap every process that you're running inside a container. So in some sense, they just kind of stopped existing. You didn't really have to think about the fact they existed because you may as well just put everything inside a container. And also in some sense, we didn't really have to worry anymore about servers because servers just become these homogeneous things that run containers and all the actual dependencies are inside the container. And then we got cluster schedulers in front of these homogeneous container running servers that essentially just turned your infrastructure into one big process list. And your infrastructure then starts to become something that looks like a really big computer. In the same way that you can run PS on your laptop, you can now run PS on your infrastructure and just see everything that's running. And the interesting bit about this is not all of the incredible technology underneath that's making this happen, but from the developer's point of view, all of the stuff that's missing here. Like from the developer's point of view, the infrastructure has become a whole load more simpler. And none of this stuff is new. Like, you know, as mentioned in the last talk, but this is going to be a repeating theme, I think, is that, you know, distributed systems and distributed operating systems are nothing new. This has been done by people who do supercomputing for decades. But there is something new here that is interesting for us, particularly for presumably most people in the audience here who write stuff for the internet. And the new thing here is how computing is supplied, and that is the cloud. In the past, you were sort of constrained by the number of computers you had and the size of the room that those computers had to go in, but that's just not the case anymore. We have this sort of infinite supply of computing that comes sort of out of nowhere. So in some sense, now we combine containers and cloud. That computer that I was talking about is really just one enormous computer that we run code on. We don't really have constraints anymore. And this is kind of been made possible because we have containerization that allows us to boot up, you know, to wrap up our application inside all of our dependencies inside something and have it boot up really quickly anywhere, regardless of where it is. So that kind of generally is sort of a trend that is happening. So why am I talking about this? Well, serverless, in essence, is a way that allows you to run code on this internet-sized computer. It's about treating the internet as just one big computer that you can run code on and not having to worry about where it is being run. And the reason it's happening right now is that we've had these two things that have been around for a long time, you know, the internet and, you know, distributed system stuff. But the timing right now is perfect, where suddenly those things are becoming good enough that they're coinciding. And serverless is happening because of the intersection of containers and cloud, and it's allowing us to do this sort of stuff. But I'm much more interested as well in all of the stuff that surrounds this. Like serverless is one step here, but if we get out of this myopic view of just what serverless is and this single sort of technique and see the context of what we're doing, we can see it's sort of part of a much wider trend of how we're building distributed apps. And I want to talk a bit more about that because it's really interesting. But first, I'm going to show you a demo of some of this stuff and how you can actually use some of these serverless techniques in practice with some actual code. So I've got a Python shell here. This Python shell is configured to point at a Docker swarm. And what swarm is it's a thing that kind of turns a bunch of computers essentially into a single thing that looks like a single thing that you can run Docker containers on. And for complicated reasons, I'm running in this on the standalone swarm, not the new Docker 112 swarm mode. Docker 112 swarm mode is better in basically every way, but it's missing a crucial feature that makes this possible, which is coming soon. If you're interested, talk to me afterwards. But, you know, it's basically the same thing. What I've got here is a Docker client, and I can open up a Docker client here. I'm essentially running a process, and that's the thing I want to demonstrate here. And in the past, on a single computer, what you would have done is you would have done a fork exec. And what this essentially does is it spins off a clone of the current process and then replaces the process with another process, in essence creating a child process, which is the process tree that you're probably familiar with on a single computer. But the problem with this is constrained to the size of the computer that you're on. And in a distributed world, let's say we're running a web server and we want to run a background process to process an image, well, we can't just do a fork exec because that'll, you know, you'll run out of space on the node that you're running. So if we're doing this distributed system, we'll think, okay, well, we need some kind of way of running this code on other machines. Let's have a worker process that's running somewhere, and we can scale up that worker process. And then how do we get how do we run code on that worker process from our other application where we need some kind of message passing system? And then we have this message system that we need to make reliable and we need to scale, and we have this worker system we need to make reliable and we need to scale. And it's just a big bundle of complexity. we sort of figured out how to do this now, but it is an extremely complex system. But now we've got these cluster schedulers. Why do we have to do this? What if we could just do a sort of fork exec over the network? And this is sort of something in Docker world which is a little bit like this. This is essentially a little bit like a fork exec, but it's not tied to the current computer that you're on, because we specified an image which contains all of the dependencies for that command that you're running. So this can run anywhere. So we can send this as a HTTP request across the network to another computer which can run this. But that thing on the other end of the network also doesn't have to be a single computer. That could be a thing which just runs it on a cluster wherever there's free resources, because it doesn't actually matter where it's running. So we've suddenly got this thing which lets us run processes on a network wherever they may be. And this is kind of the thing that I'm doing here, is that I've got this Docker client here which is pointing at a swarm which is serving an API which just runs processes on a cluster. And I can specify an image to say what's in it. And I'm running this from Python, but because this is Docker, I can actually just run any language. So I can call a function from Node.js, for example, and pass it some arguments, which are just command line arguments, and then run this. And what this is going to do is this finds some free resources in my infrastructure, runs the command, gets the output of it, and then returns the output to me. So I'm basically just running a process here on what is a cluster-sized computer, and if this was the cloud, a infinitely sized computer. What's really neat about this as well, and the reason this links up with what's going on in serverless, is I'm running this a bit like a function. I pass some arguments, and I've got some output as well. And that's a really interesting thing, because we can now essentially run Docker containers, run processes, and use them as functions as well. So how might this work in an actual real application, an actual app? So this is a application that we've got here, which is a voting application. It lets people vote on two different options. And when users vote in this application, it pushes their vote onto a message queue. And then there's a worker process which then picks up this work, does some processing on the vote to make sure that it's not a fraudulent vote. And then once it's validated that, it puts it into a database. And then for the people who are interested in the results, there's a results application which sits there and views the results from the database. And considering what I've just talked about, there's something here that's we can very obviously make much simpler here. Instead of having a message queue and worker system, what we could do is this voting app could actually just run a Docker container to process the vote on a cluster. So let's take a look at this in code. I've got the code here. And this is the function here which processes the vote. And if it's a post request, what it does is instead of pushing that vote onto a message queue, what it does is it actually just runs a Docker container directly on a swarm and passing it the arguments, and then it detaches. You see this detach option here, which is the same as the -d option in Docker run, which essentially just means run it in the background, and then the HTTP request can return immediately, and this work is done in the background, just like a worker queue system. So that's kind of neat. What we've done here is we've eliminated two long-running processes in our infrastructure that we had to maintain and scale, and just replaced it with a thing that gets called on demand and scales on demand, which is just a whole load more simpler from the point of view of the developer. There's also a couple of other things here which we could eliminate, something that actually looks curiously similar to the worker queue system, and that is our HTTP front ends. They're just things that are sitting there waiting for HTTP requests, and when it gets an HTTP request, it does some work, returns a result, and then sits there doing nothing, waiting for another HTTP request. We could replace this with containers in a similar way. What if we had a container that just processed a single HTTP request? Well, turns out this is actually a solved problem, and this was solved back in the 90s with CGI. So what I've done is this container here, if you were looking closely, you would have spotted this. We're using a CGI handler, which is a thing that has basically been in Python forever, because this is how we used to write web applications. And down here, instead of running a web server like you would normally do, this is using the CGI handler. So when you start up this process, it will return immediately with an HTTP response and shut down, which is perfect for what we want. And then what I've also got in this diagram is just a little entry point server, which essentially just sits there waiting for HTTP requests. When it gets an HTTP request, spins up a Docker container and passes the standard out back to the HTTP response. So that is basic serverless application. Oh, there's another thing as well. There's another application in this, the results application as well in this application, which unfortunately was written in Node.js, which doesn't have any support for CGI. So I rewrote it in a much better language for our sort of serverless CGI future. So I rewrote in Perl, which just works. And so this application just basically sits there and queries the database and returns results to the results application. I'm really happy that I could use Perl for this. So let's boot up this application. I've got it here. It's just a Compose app. It's two things, which is the database, which unfortunately is still long running, and then the entry point server, which just sits there doing nothing, waiting for requests. And I can open this up in my browser. This is the voting app, which has just been served by CGI, and a result app, which is the same thing. And then I vote for cats. This is spinning up a new container to serve the post request, which is then spinning up a new container to process the vote, storing it in a database, and a results app then receives that result. Yeah, that's a serverless app with Docker. That was a bit of a joke. Like, I'm not really suggesting that you rewrite, your web front ends in Perl and use CGI. But there are some practical techniques that you can use here, and some interesting stuff that we've actually done, which are actually practical to do right now. One of those things is packaging functions as containers. This is, if you're already using Docker, this is a really easy way to start using sort of serverless techniques in your applications. And then once you've got sort of bits of functionality in your application packaged up inside Docker containers that are spun up on demand, you then run them on a swarm, which will allow them to scale up to demand. And then there's another really interesting technique here that we used, which if you're feeling adventurous, you can sort of play around with. And it's the thing that made this really interesting as well, is that we then run containers from other containers. So the entry point was running in a container, which spun up the CGI script, which was running inside a container, which spun up the worker process, which was running in a container. So this was all really shipped as a single container, but then it could spin up more bits of its application as it needed on this really big computer that we're running. And that's a really interesting technique. It's still very early stages because there's not really a good way to do this at the moment, except for injecting the Docker socket inside a container, which is a really bad idea. But we basically need to build some tools to make this possible. And that's a bit about what I want to talk about next, which is what is going to happen next. Well, that web server we had serving HTTP requests, CGI is not entirely practical for that. Because like spinning up containers is really fast, but it's not entirely free. Like there are tens, hundreds of milliseconds until that container is booted up and you've got the output. Which is okay for most things. It's certainly okay for background tasks, which is why that is actually a practical technique. But for HTTP, if it's user-facing, then that's kind of not good enough. So how might we actually design this? Well, if we break out of the constraints that our HTTP request has to be a function, which sort of serverless dictates in some way, and think about it in context of like, okay, we actually just have a really big cluster-sized computer here. What can we do? There are actually some more interesting things we can do here, and we can take inspiration. If we model our infrastructure as a big computer, we can actually take inspiration from how single computers do this. And if you imagine an Apache server running on a single computer, what it does is you spin up the parent Apache process, and then to process more load on multiple CPU cores, it spins up a bunch of child processes. But those child processes are constrained by the size of the computer it's on, because Apache runs on single computers. But what if we weren't constrained by the size of the computer that it had to run? How could we do this? Well, we could ship our web front ends as a container, as a process, that spins off child processes to actually serve those processes. And when it receives more load, it can spin up more child processes to handle that load. And it can spin up as much as it likes if it's running on a cluster, because it can just keep on spinning up child processes. And when it receives less load, it can spin them down again. So in some sense, this is a bit like an auto-scaling web front end that you ship as a single container, like you ship Apache as a single binary on a computer, and it can just sort of work. And what is a serverless database? Well, in some sense, this is a bit silly because we're trying to limit ourselves again by what serverless means. I mean, you could write a serverless database. It's sort of SQLite, really, where you for every database request, it loads up the database off disk, processes the request, and returns it back to you. That would be possible. But again, it's not really practical because you probably don't want to load a database off disk every time you make a database query. But instead, we could try modeling our infrastructure as just a big computer. What could it do? Well, we could ship our database as a container, again, a process, that then tries to introspect the structure of your cluster and runs the right number of shards and replicas on your cluster to make it work and to make it scale up to the size of the computer you're on. In the same way that if you run it on a single computer, a piece of software might figure out how many CPU cores you've got. A piece of software running on a cluster could figure out how many nodes you've got and how many racks and data centers you've got and stuff like that. And for a lot of these things, it's really just trying to escape the complexity mindset. Like, a lot of the time we try to think about how to run applications on multiple computers when really most applications don't need that level of optimization. Like, when you're writing software for a single computer, some people need to worry about what CPU core something is on and whether something's in the L1 cache, but most people don't, because computers are fast enough. And this is sort of what we try to do with Docker, where this technology that existed for a long time. Containers have been around for ages, but they were just really hard to use. So we put a much simpler abstraction on top for developers, which meant that most people could use this. And we're sort of the same stage with a lot of these distributed applications, where we have all the foundations, we have all of the foundations, but the real thing that is missing is the developer tools and design patterns and abstractions that are sitting on top of this thing to actually make it possible for most developers to actually be able to build stuff. And I think the analogy of CGI here is kind of apt, because back in the 90s, CGI was incredibly exciting. Before CGI, the web was just this thing that served up static files. But suddenly you could send data to the web that could process it, and you could change things on the web for, change stuff that you were seeing on the web and change things that the whole world was seeing on the web. This was incredibly exciting. But CGI was terrible. But it was compelling enough that we just used it anyway and got around all of its flaws. And we're at the same stage right now with distributed apps, where we've got all of this exciting technology. We've got all of these exciting clustering technologies and so on. But all of the tooling is just really crap, but we use it anyway because it's so compelling. And I think serverless is kind of this glimpse of the future that we're seeing of how we're going to be building applications for these internet-sized computers. But it's a really small part of what the future is going to be. And there is so much more yet to be done. So if you're interested in building tooling, I've got this website here with a bunch of links off to stuff and a bunch of things that need to exist that don't exist yet. So if you're interested, please go there. And if you want to talk to me about it, these are my contact details. Thank you.